Hi class, we continue in chapter 3 talking about parallel and perpendicular lines, and we're going to move into section 3.6. And this is going to be our first section on coordinate geometry, and what we're going to talk about is the slope of a line. So we have three objectives in this section, and this video is going to be a little bit longer than a lot of the previous ones. But the first thing we want to do is we want to find the slope of a line. I'll talk about how you do that. Then we want to interpret the slope-intercept form of a line, all right, in an application. So I'll introduce what's called the slope-intercept form. And I have this example picked out about prices of tickets at Disney World. It's kind of interesting. And then finally, what we want to do is we want to compare the slopes of parallel and perpendicular lines. Right? So we know that parallel lines never intersect, and perpendicular lines intersect to form 90-degree angles. All right, so the slope of a line. So we measure the slope of a line as the ratio of vertical change to horizontal change. And usually slope is designated by the letter M. All right, so what do I mean by vertical change and horizontal change? So take this point 2, 1 on this blue line, and this other point on the line 4, 5. The horizontal change, if I go over 2 units and then up 4 units, that's up is the vertical. So you can think of that as the Y, and this is the X. I get to that point. If I go down here, the point -2, -7. If I do the same vertical change, up 4 units, and then the same horizontal change over 2 units, I get back to another point on the line. Right? So this vertical change and horizontal change, or horizontal and vertical change here, will always get back to points on the line. All right, so the slope here, remember how I said it as the vertical change is that kind of that Y? All right, so the slope is the change in Y divided by the horizontal change, or that change in X. So my slope M here, well, the change in Y, the vertical change here was 4 units, and the change in X, the horizontal change, was 2 units. So 4 divided by 2 gets me 2. So we can also think of slope kind of as a rate of change between the 2 points. All right, but there's a more concrete formula for this. So here's the formula. The slope M of a line is the ratio of the vertical change, the rise, to the horizontal change, the run. All right, so between two endpoints. So ratio is division. So you might have heard of slope as this rise over run. So a line contains the points x1, y1, which will be right here. What that sub means is this is the first x value, this is the first y value. And then over here we have another point on the line which we'll designate as x sub 2, y sub 2. It just means the second x value, the second y value. So my slope is equal to rise divided by run, which is equal to y2, the second y value, minus y1, the first y value. And then the denominator is x2 minus x1. So it always has to be y2 minus y1 divided by x2 minus x1. Or you could have it as y1 minus y2 divided by x1 minus x2. Doesn't matter as long as, if the first x value is whatever x value you pick down here, you put the corresponding y value here, and so on. All right, so let's do an example. All right, this is about finding the slopes of a line. So I've got this graph over here that's got a bunch of different lines on it. I've got line A, B, line C, and line D. What I want to do is I want to find the slope of line B here, and then I want to find the slope of line D right here. Right, so this one looks like it's a downward sloping line, and this one looks like it's just a vertical line. All right, for line B, we're going to use the points -1, 2, and its other point 4, -2, in the slope formula. So M is equal to, I'll take the y value here, 2, and I'll put its x value, corresponding x value, right under, just like I said. Then I'm going to subtract this y value, so double negatives here, -2, minus this x value here. So when I simplify, 2 minus 2 becomes 2 plus 2, which is 4. Minus 1 minus 4 gives me 4 divided by -5. Or the slope of this line is -4/5. The same thing here for line D. We use the points 4, 0 and 4, -2, right, as the slope formula here. So M is equal to 0, and then put its corresponding x value here, 4, minus, well, -2, that's a double negative, and put the corresponding x value for -2, which is 4, here. So my slope becomes negative, negative is positive. So 2 divided by 4 minus 4 is 0. So that's weird. Like in mathematics, you probably have heard you can never divide by 0. So what we say is the slope of this line is undefined. And the reason you could think about it is the vertical change to go from this point to this point is 2, but there is no horizontal change. So that's weird. So there's slope whenever you divide by 0, we say it's undefined. When you have an undefined slope, this is a very specific type of line. It's a vertical line. All right, the slope of a line can be positive, negative, 0, undefined. The sign of the slope tells us whether the line rises or falls as we follow it from left to right. The slope of 0 tells us that the line is horizontal, and an undefined slope tells us the line is vertical. So positive slope, as I go left to right, you go up. Negative slope, as I go left to right, you go down. 0 slope means it's just a horizontal like this. And an undefined slope, so whenever you have that divide by 0, you have this vertical line like this. All right, so the slope of any vertical line, as I said, is undefined, and the slope of any horizontal line is always 0. All right, now what we want to talk about. We want to talk about linear equations. So the slope-intercept form of an equation of a non-vertical line is y is equal to mx plus b, where m is the slope and b is the y-intercept. So b is where it crosses that y-axis. So the equation of any line, like this, say this blue line A, I want to find an equation that describes this line. It's going to be in this form. The y value is equal to the slope of the line times the x value plus b, the y-intercept. All right, so the y-intercept is the point 0, comma b, and is the y-intercept point where it crosses the y-axis. So the point slope form of an equation, so this one, let me go back here, the slope intercept is what we always want to simplify to. But there's this other form called the point slope form of an equation of a non-vertical line is y minus y1 is equal to m times x minus x1. And this is where that m value is the slope and x1, y1 is any point on the line. And what you want to do when you plug it into this equation here is you want to simplify it to get it into the slope-intercept form. All right, let's do an example. Find the slope and y-intercept point of the line 3x minus 4y is equal to 4. Well, remember, the slope-intercept does is it gets the y value all by itself. So I'll start with my equation. The first thing I'll do is I'll subtract the 3x over. So I move the 3x over. Now I want to get the y by itself. So I divide by negative 4. And when I divide this side by negative 4, I have to divide everything else by negative 4. So negative 3 by negative 4 becomes positive 3/4. This negative 4 and negative 4 cancel. You're just left with y. And 4 divided by negative 4 just gives me negative 1. So the slope here of this line, so it's y is equal to mx plus b. The slope is 3/4, and the y-intercept here is negative 1. All right, let's do another example. All right, this is an application problem. All right, this is predicting future prices. So the adult one-day pass price for Disney World is given by this equation here. So this is what we call a time series plot, this red line here. These are the actual prices at years since 2000, right, where x is the number of years since 2000. So when x is equal to 0, that's the year 2000. When x is equal to 1, that's 2001, and so on. And what we're doing is we have this non-linear line because it doesn't follow a perfectly straight line. We estimate it with this blue line here. That's the equation y is equal to 3.2x plus 48. All right, so here's the thing. Use this equation to predict the ticket price for the year 2020. All right. Second thing that we want to talk about is what does the slope of this equation mean? And what does the y-intercept point of this equation mean? All right, so I've got this equation here. Y is telling us the dollars of the ticket price, and x is the number of years since 2000. So first here, A, to predict the price of a pass in 2020, we need to find y when x is 20, right? Since x is years since 2000, all right? 2000 corresponds to x is equal to 0, and the year 2020 corresponds to x is equal to 20. So you're just going to plug that 20 into my equation for x here. So you're going to get y is equal to 3.2 all right, times, forget the typo here, 3.2 times 20 plus 48. When you plug that in, now what's a typo here is the 1 and the 2 should be parentheses, so forgive that typo. The price should be $112. And having gone to Disney World this actually last year, that's about right. Okay, it's pretty close. All right, so we predict that in the year 2020, the price of an adult one-day pass to Walt Disney World will be $112. All right, so the slope of the equation is 3.2. All right, that's that first part. We can think of this number as the rise over 1. All right, so or the rate of change. All right, so 3.2 divided by 1. So that's the horizontal change, or excuse me, the vertical change in y over the change in x. Well, y is dollars. So this means that the ticket price increases on average $3.2 every 1 year. Now the intercept is 48. All right, so that's saying when x is equal to 0, the price was 48. So the year for that, all right, well, the year, this means that at year 0 or 2000, the ticket price was $48. Okay. All right, let's talk about parallel and perpendicular lines. So two non-vertical lines are parallel if they have the same slope and different y-intercepts, as you can see in the graph here. All right, they'll never intersect if they have the same slope but different y-intercepts. Now, perpendicular lines, so two non-vertical lines are perpendicular if their product, all right, is equal to -1. So if this slope, another way of thinking about it here, is if this slope here, this first one going to the right is equal to a over b, if I want their product to be -1, the perpendicular line has to be their slope has to be the negative reciprocal, or negative instead of a over b, negative b over a. All right, so are the following pairs of lines parallel, perpendicular, or neither? All right, so remember, parallel lines have the same slope. Perpendicular lines, their slopes are negative reciprocals. All right, so I just want to take these two lines and these two lines and figure out if they're parallel or perpendicular. All right, so what I have to do then is I want to find the slope of each line by solving each equation for y. I got to get y by itself. So in A here, the first thing I'm going to do is I'm going to move the x's over. All right, so I'm going to take this 3x plus 7y is equal to 4. I'm going to move the 3x over. Then to get the y by itself, I'm going to divide everything by 7. And when these cross out, this first top one, the slope intercept form, y is equal to -3/7 times x plus 4/7. So -3/7 is the slope, 4/7 is the y-intercept. Doing the same thing for the other equation. Move the 6x over. Divide everything by 14. When I simplify, I get y is equal to -3/7 x plus 1/2. So you notice right here, they have the same slope, different y-intercepts. These lines then, all right, because both lines have the same slope and different y-intercepts, the lines are parallel. Next example here, let's do the same thing. Take the first line, move the x over, so add x to each side. Divide everything by 3. These 3 cancel. When you have a 3 in the bottom and only an x in the top, I can take it out as 1/3. So y is equal to 1/3 x, and then 2 divided by 3 is just 2/3. If I do the same thing on the other side, subtract the 2x over. Divide everything by 6. Cancel the 6's here, simplify this. And y is equal to, oh, this is weird. This is 1/3 and this is -1/3. Here the intercept is 5, 6, so they have different intercepts. The slope's not the same, right? This is 1/3, this is -1/3, so they can't be parallel. If I wanted to check that these were perpendicular, they would be negative reciprocals of each other. So if one slope was 1/3, perpendicular line, the slope would be -3/1. So the slopes are not the same and their product is not -1, so the lines are neither parallel nor perpendicular.